I will remind you of the next 7-day schedule. So today we've got Buzz Lightyear notes. Okay. Tomorrow, Chromebook and earbuds day. Okay. So bring your Chromebook, bring your earbuds. You'll take notes while watching a video. Monday will be Infinite Geometric Series Application Day. Tuesday is a formative. It'll probably be a formative very similar to last week's, where you'll check it right away so that you get instant feedback, so that because the test is on Thursday. Wednesday will be a review day, Thursday will be the test. Okay? So that's the plan for the next week. And then Friday, because it's Battle Royale Day and some people are leaving a day early and all that fun stuff, Friday's going to be the day of the rat. So Rat is planning that day. She hasn't told me what movie we're watching yet, but we're supposedly watching a movie. Huh? What?
She's like,
Oh, well, she's got plenty of time to plan then. So she might have the corona?
one of the girls on her cheer team.
Oh my
Really? Oh, that's
She's like,
great.
yeah, she's been freaking out since yesterday.
So what happens if she's not here next week? Then what are we doing?
Then it's Finding Nemo.
Okay.
How about Finding Dory?
What are the symptoms?
She told me that it's got to be Finding Nemo.
Finding Dory is the second one.
I get it. We might even just do Toy Story. You know, with Buzz and
Which Toy
Woody.
Story though?
Always one. You do. 4 does not exist in the Linsmeyer household.
Okay. I haven't seen 4 yet, so.
Yeah, it doesn't exist.
Okay.
All right, here we go. Toy Story 4 does not exist.
Wasn't that bad?
It wasn't bad. It was good. It's just not how I wanted the franchise to end. Yes.
How else are they supposed to end the franchise?
Forky's great. The movie's great up until the last 10 minutes. Then, done.
I haven't seen the movie, so.
Done.
I don't know anything about it.
To quote my wife, done. All right. So, for this part, stop. For this part, it's all just visual. Okay? It's all visual. Okay? Promise. I'll tell you when you gotta start writing stuff down. Okay? So it's a visual type of a day. Okay? So, I've got 2 different series up on the board here. Okay? Both are geometric. In series number 1, the R value is 1/3. Would you agree?
Yes.
2/3 divided by 2 is 1/3. Okay, so we have an R value of 1/3. On series number 2, we have an R value of 2. Okay, so we have 2 different series. Now, if I were to graph these 2 series based upon their value and their term number, so the X coordinate would be the term number, the Y coordinate would be the value of each term, it would look like this. Oops, I should have gone like this. It would look like that. Okay. Series number 1 seems to get smaller and smaller and smaller and smaller as we're going along. Series number 2 seems to get bigger and bigger and bigger and bigger. Would you agree? Okay. Based upon those 2 graphs, in the mathematical world, we call series number 1 converging, because it's converging onto what's called a sum. We call that a sum value. We can find the sum of this infinite geometric series, because the farther and farther we go, the smaller and the smaller our values get. So small that, I mean, even in this one, you get out to about the 10th term, and you're adding a number that's so tiny that it really doesn't affect your total sum anymore. Whereas in series number 2, if I get out to the 10th term, that 10th term is so big that it's probably almost doubling the sum with every next term. You understand that? Okay? So that's a divergent series. Okay? And I can't find the sum on a divergent series because that next term is so big, it has such a big effect on the sum value. Whereas on a convergent series, it's so small that it doesn't have an effect. Okay? If we have negative R values, okay, so now I've got negative R values. So here is my 2 series. My left series number 1 has an R value of negative 1/2. Series number 2 has an R value of negative 2. Again, series number 1 converges upon 0. Yes, it flip-flops back and forth, but it's always getting closer and closer and closer to 0. So that number, if it's positive and we're adding to our sum, or if it's negative and we're subtracting from our sum, doesn't really have that much effect on the sum total. Whereas on a divergent series, okay, it's getting larger and larger, and so you're adding a huge number, then you're subtracting a huge number. Then you're adding a huge number, subtracting a huge number, and so on and so forth. So the sum would exist over here in series number 1, but it would not exist in series number 2. If R is 1, okay, so if R value is 1, the graph would look like a straight line, okay, because the value would always be 2. Doesn't diverge, doesn't converge, it just stays constant. Okay? And we can't find that sum either because the next term is going to be 2. So that's going to affect the sum total. And the next one's going to be 2 more. 2 more, 2 more, 2 more. Always going to be adding 2. So that's not going to happen. It can't get the sum. Okay? So here's where we start writing stuff down. In the infinite sum case, okay, so our infinite sums would have dot, dot, dot at the end and no extra number. It would keep on going forever. Or, oops, that's a bad sigma. We would have infinity up there. Those are the infinite series case, finding the infinite sums. So R value is where a sum exists. R, simply put, our R value has to be between -1 and +1. If it is outside of that range, your answer is no sum exists. Okay? And you're done with your problem and you're moving on with your life with a smile on your face. Okay? The formula for an infinite sum Now you think about it, we're adding an infinite amount of terms, so this formula is probably going to be super complicated. Okay? Right? Because you think of the sum formula for just a finite geometric series, that was that g sub 1 times r to the n power minus 1 all divided by r minus 1, that one. Okay? The sum formula for an infinite geometric series is that. The first term divided by 1 minus r. Danielle would know me, I was joking about the whole complication of the formula. Sorry, am I in your way, my dear? Okay. Oh, still in here. Now I'm in cat's way. I'm telling you, one of you people out here that is tech savvy needs to invent me an iPad app that I can be walking around with the iPad, and that's my entire screen. We have one right now, but I only get to write on something that's about 2 square inches wide, and that's like supposed to be the whole screen. Okay? It's very hard to do. Whereas if I had an iPad and that mimics, mirrors, yeah? Then I would never stand in front of you. I'd sit in that desk back behind Grace, and I'd talk from there. And unfortunately, then Lainey couldn't be on her phone. Insta-facing, snapgramming.
Why can't you use a Chromecast?
I don't have Google Chrome. What do you mean a Chromecast? Yeah. I'm an
You
Apple.
can still use, because I have a Chromecast on my TV and I can mirror it from my phone to the TV.
But that's still so small.
So we're not that powerful. Yeah, you can still use a tablet then.
Again with the shouting. Good God, man. I just gave you $1 billion idea, and you're yelling at me for it.
And Lainey's
I
right.
thought that's what initial reaction.
$1 billion I just handed to you, and it's not good enough. All right, so find the sum if it exists.
Wait.
What?
The thing that you have it on now, is it a phone?
No, it's an iPad, but it's just a little part of because it's the program. Yeah, it's the app or the pro. It's actually a program.
Can't you write on your computer right now
No, it's not a touchscreen.
though? Well,
Yeah, no,
you
it's,
can still scroll on it.
I can scroll on it, but I can't write on it. Yeah, it's not a touchscreen. The last computer I had was a touchscreen, and it was phenomenal.
So why do you want that?
Because we all went to Max. All right, so here we go. Find the sum if it exists. So the very first check that you need to do is you need to figure out what your R is. In this particular problem, what is our R? 1/4. It's still whatever number in a rule that has an exponent attached to it. That hasn't changed. Okay? So my R value here is 1/4. Now my question to you is this. Is that R value in between -1 and +1?
Yes.
Yes. So does the sum exist?
Yes.
Yes, it does. So we can go to our sum formula. Now we just have to find our first term. How am I going to find my first term? CJ, I saw your hand first.
You put 3 times the 1/4 and then you put 1 minus 1.
So we plug 1 into my rule.
Yes.
1 minus 1 is
0.
0. 1/4 to the 0 power is
1.
1. 1 times 3 is 3. So my first term is thrice. Okay. I've got my G sub 1. I've got my R value. Shabam. Let's go to the formula. S. And notice how we don't have to say how many terms there are now of our sum. Because it's infinite. So it's just S now.
Now I have a question.
Oh,
How can there be a sound?
I take my high five back.
That's okay.
Okay.
How can there be a sound if it literally is off forever?
Because those terms at the as the farther and farther in along the line of terms we get are so infinitesimally small that it's like adding 0 every time. Yep. I had said that, but I said it over there before.
Yeah, I think you did.
I get it. You were too busy thinking about how not to get the coronavirus.
I really was.
COVID-19. First term is 3. 1 is 1 minus our R value is 1/4. Now, Lainey, you're going to be mad. But what do we love in this class? Fractions. So we're going to leave it in fraction form. Okay? 1 minus 1/4 is what kind of a fraction? 3/4. Okay? So we've got 3 divided by 3/4. Now, thinking back again to 4th grade, dividing by a fraction, we multiply by the opposite reciprocal? No, that would be multiplying by a negative then. Opposite would be negative. Yeah. So we just multiply by the reciprocal. So I take 3/4 and I flip it over. So that's going to be 3 times 4/3. What? So it's just 4. So the sum here is 4. Now, logically thinking about it, our first term was 3. With me? The rest of the terms to infinity total 1. Okay? Your first term in an infinite geometric series that you can find the sum of, your first term is going to be the biggest term. Okay? Questions, comments, concerns, clarifications? Ready to try one on your own? Yes. Let's do it. Yeah, buddy. I feel as if we're missing a few. Hot off the presses, brand new attendance sheets. 24, 6, 8, 10, 14, 16, 18, 21. So we're only missing twice. We're going to use the blue pencil today. Rat, coronavirus, self-quarantine. R value,
There's 1/2.
negative 1/2 for an R value. First term. First term is 1? Yep, I would agree that the first term is 1 times negative 1/2 to the 1 minus 1 power. 1 minus 1 is 0. Negative 1/2 to the 0 power is 1. 1 times 1 is 1. So my sum then is going to be 1 divided by 1 minus my R value is negative 1/2. 1 minus negative 1/2 is like 1 plus negative 1/2, which is 3/2. Because 1 is 2/2, right? Plus 1/2 makes 3/2. Agree? The reciprocal of 3/2 is 2/3. 1 times 2/3 gets me the sum of this infinite geometric series is 2/3. Yes? No? Maybe? That's a yes, no, maybe. This, not just a half. Good? Let's do one more.
I have a question.
What's up?
So when you multiply by the numerator, like, do you always multiply the numerator to a fraction?
What do you mean?
Like,
So I think of this as 1, oops, wrong color. I think of this as 1 over 1, and then you multiply across, and then reduce. No, we flipped it already. We flipped it to get to that point. Okay? Go for it. Find me the sum if it exists. Find me the sum if it exists. If it exists. If it exists. You didn't know that I was a singer. Professional. I sing professionally in my shower. Yes. Quadruple platinum. That good. I also sing in the tractors too. The acoustics is actually better in the tractors. It actually is. Because it's all in the cab, so it's all closed. Crank some tunage. Why are you done so quickly, Hunter? Why not? What?
oh, what?
Yep. R value is too big. Each term's getting bigger and bigger and bigger and bigger.
You want it to get small.
We want it to get smaller. Yep. The only way we can find the sum is if the terms get small.
What's it? Thank you. Lens. Say that we kept on going with it. Would the sum just be, would the sum just be error?
No.
Would it just be really big?
It would just it'd be goofy because if you would actually have done this problem, so you would have done 1 divided by 1 minus r. Well, 1 minus 3/2 would have been negative, so you would have done 1 over negative 1/2, which would have been negative 2, right? Well, the downfall is they're always going to be positive. So the sum of a positive series is negative. Okay? So that wouldn't have worked out there. Okay?
Good question.
Yeah, very good question. Your homework this evening, and yes, still do tomorrow. Oh my God, you will probably get it done in the next 10 minutes.
You're overestimating my abilities.
Grr! There's 2 things you need to calculate for these problems. Sometimes there's only one. Luckily, it's not this one.
Oh,
It's this one.
That's true.
You know what I mean? Okay. So this one's hydrate or dihydrate.
Yes.
Bless you, whoever sneezed.